Okay, so you have to complete the square. In these examples, we're looking at where the b term is negative. So if you haven't seen the video where the b term is even, I suggest watching that one first because it introduces the method a lot better. And the negative is getting toward the territory of, do I want to complete the square? If you're not confident with fractions, you certainly do not want to do this one if there's an alternative. But I'd say fractions are one of those things that one ought to master anyway. Let's take a look at this. In the first example, we have a negative number in front of the x, and that's the crucial point that makes this a little bit more difficult. But we'll stick with the same method that we've seen in the previous video, where we decide to halve the b term. Now I'm going to stick with fractions. Some people will want to write 2.5 here, but I think you'll see that later if you stick with fractions it's a lot better. If you've got a calculator, you might wonder, what's the point in even having a choice? Doesn't matter. Well, if you don't have a calculator or you just want to get better at fractions, there's a number of reasons, but fractions are quite elegant. So we have half of that. Well, it's quite easy, isn't it? Just write it over 2. That's literally an expression for half of it. You don't even need to know what half of it is. Sometimes that's a blessing, because finding half of it, odd or strange number, is difficult. Anyway, on with the show. We're now going to subtract the number that's inside there squared. And since the number in this is 0, we're not going to be adding on anything at the end except for 0. I'm not going to write that. It's just how it is. We'll see more interesting point there in the next example. And we'll just tidy this up. So we get x subtract 5 over 2. And we can square this pretty straightforwardly, like so, and I'd probably just leave it like that. For those people that really want decimals, this might be a good time to convert it once this has all been done, because working with fractions is a lot better as you go along. What have we got? So we've got x subtract 2.5, and then 25 over 4, so 12 and a half, 6.25. And this would be useful for when we're plotting or finding the minimum or maximum point. As you can appreciate, there's more exact. And if we're looking at where that is on a scale, it's in your face and done. This, however, is much more elegant and nice if you can handle working with fractions. So pretty straightforward there. Let's have a look at how it changes slightly with the full quadratic expression. So we're going to complete the square, and we're going to halve that term in the middle. So just literally write it over 2, straightforward. We're going to subtract that term now, squared. And then we're going to, I should say add, but this one's take away, it's still an add. We're going to add that negative number at the end and tidy it up. Now, tip is to get the denominator the same. If you have a calculator, well, you've got a calculator, so that's it. So in to sort of do it all at once, I'm going here to have 9 over 4, which I want the number at the end to be over 4 as well in order to combine it. So I think to myself, okay, what divided by 4 gives me 10? So that's going to be 40. And then it becomes a little bit more easy to tidy up. So we get x subtract 3 over 2 squared, and we're going to subtract 49 over 4. And this is going to be like the way that we find the minimum and maximum, or we could put it equal to 0 and rearrange it. Slightly more difficult when the b term is odd. So you have to weigh up whether this method of solving or even finding minimum or maximum or whatever you want to do with it is the best way to approach it.